Okay, so welcome to the last session today in this room. It's about Java on wearables. It's more on the wearables than on Java. Let me tell you this up front. Yeah, you might guess from the picture that it's related to some kind of sports wearable. That was the original idea. My name is Gerrit Grunwald. I'm working for Oracle as a Java technology evangelist. And because I'm working for Oracle, I have to show you this slide. I will give you a couple of seconds to read it, understand it, and then that's enough. Wearables. So what is it? I tried to figure out some kind of definition. It's a miniature electronic device worn under, with, or on top of clothing, and it needs more computational support than hardware-coded logic. So this is some general description what a wearable could be. In principle, this would also fit for my notebook, right? So if I put my notebook in a backpack, it would be some kind of a wearable, except the miniature electronic device. Well, some examples, sure, you will find something like headphones or glasses, you know, that stuff. Then for sure, watches, clothing, which is really interesting, insoles. This is very fascinating, and lots of more things you will find on the web. So use cases, I'm pretty sure you know that it's fitness and health tracking, then you have location and directions like GPS, navigation and all that stuff. Then you have note-taking and productivity, not really clear at the moment what that means. And there is sure something like informational topics for wearable devices. And if you have a wearable device, then you have to meet some requirements to really make it wearable, and that might be small form factor. Sure, this is important. Then smart power management, which is even more important, and there's a relationship between those both points, because if you have a small form factor and you don't have smart power management, means you need a big battery to keep it running, and that is against the small form factor, right? So then there's something like connectivity, which is also very important, and a point like life proof. Life proof, this is fascinating. I will explain shortly what these things means. So small form factor, sure, small size. That's obvious. Lightweight, also, and unintrusive. So I mean with unintrusive, this is my wearable. I will come to this later, and you see these cables hanging out. That's not very nice, but unfortunately it was not possible for me to keep them inside the case. This will be in the next version. So that means you don't want to have some wires hanging around or some other things that really affects you when you do, for example, sports or something. So the best one would be you don't even feel that it's there. Smart power management, this is, I think everything improved over the last 10 years, right? Computers got smaller, they got faster, they got cheaper, so we fixed all that problems, but batteries, it doesn't apply for batteries. Batteries are still the biggest problem for all that wearable stuff, for all the mobile stuff, you know. I think most of you will have a smartphone, and you know that you can use it one day and then you have to charge it again. Otherwise, it just runs out of battery. And this is high-end batteries, so to say high-end at these days. Maybe Tesla will change that with their new batteries. So you need something like a sleep mode strategy, because if the device doesn't do anything, so why consume power, right? So try to keep down all the processes and measuring stuff if it's really not needed. Then that seems to be obvious, but if you create it yourself, then an auto shutdown mode is really needed, because if the device is lying around, then at some point it should see, okay, nothing happens, so just I go to sleep or I shut down. And you need rechargeable and replaceable batteries, for sure. These are all points that seems to be very obvious when you think about that, but if you start creating your own stuff, then all of these points become very important suddenly. So we will go to that point. So connectivity, which is, that's the interesting part. you can connect it with a wire. For example, you have an activity tracker, you put it on your wrist, you run around the whole day, you have no idea how active you have been until you plug it into your computer, right? You need a USB cable. If you have an expensive one, you have a Bluetooth or something like that, but you need to connect it. So that means you can also use something like Bluetooth, ANT+. Who knows ANT+? Just one, two, oh, that's just a few. But Bluetooth, I guess everyone, right? Zigbee, who knows Zigbee? Oh, more than ANT+. And yeah, there are Z-Wave and many more different standards that you can use. Then there's Wi-Fi as we know it, and I put it on a different point because it's, yeah, it's something special. And then for sure there's cellular, so means your mobile phone, right? You can use 2, 3, or 4G cellular networks to connect to the internet. Well, then we have this point that I mentioned, live proof. What does it mean? When I first saw that, I thought, live proof, that sounds interesting. Well, it's things like waterproof would be nice. Drop proof, sure, would be great if I drop it on the floor and it doesn't fall apart. Dust proof, it's important. Sweat proof. And the last one, really, if you build something by yourself for sports activities, you will figure out that sweat is really aggressive to plastic. So I tried that with one of these cases, which are just a standard plastic case, and after running 5, 6 times, then it starts getting white and it looked ugly. So that means you really have to take care about that. It's nothing that you can say, I don't care, right? It's important. So let's have a look at the current situation. We will find lots of devices like whatever, Apple Watch, Android Gear, and all these activity trackers and whatever. There are so many wearable devices on the market. And most of them have predefined features, right? It's track my activity. It can measure the heartbeat, great. Others can, whatever, measure the temperature in addition. So that's nice. But there's no real standard, so you can't combine an Apple smartwatch with an Android phone, or the Android Gear with some whatever Apple stuff or other things, you name it. It's just, there's no standard. Everybody's creating his own things. And so that makes it really hard to combine these products. It's not possible. So what does it mean if you need something special? For example, the idea for my wearable was born last year during ERDEF, a conference in Sweden, where we discussed with a marathon runner, wouldn't it be nice if this runner could run on a marathon and his team can track him live? That was the original idea. And we thought about how to do that in Java. Sure, Java, right? So what else? So yeah, that first of all, it was, well, let's do it. Many beers have been involved, so we are very optimistic. And on that evening and in the morning, suddenly I found myself alone at the breakfast with a big headache. And then when the others show up, it was like, yeah, you know, it was a nice idea, but forget about it. Well, to be honest, I can't really, because I was thrilled by the idea to have that. So what do you have to do? You just have to do it yourself. Right? This is the only way you can do it. You can buy, in the meantime, you can buy some kind of things that will do similar, or that give you the ability to track stuff like that live, but this is really expensive. And then you are, again, bound to a certain system, and you can't really add something that you would like. So I got the idea, and I named it the JRunner project. In the meantime, I found out that I'm not really a big runner, so I'm more a biker, so that was obviously not the right name, but I stick to that name. So you can use that tool in principle for everything where you would like to track a location with additional stuff. You can also put it in the car or on a motorcycle or whatever. So let me give you an idea what it should do. First of all, it was read the GPS data and track that to get the location for sure. Then I would like to read the heart rate with, if possible, with some standard that I can buy in a sports store. Then I would like to have haptic feedback. That means if I have this thing in my pocket or wherever I wear it, that means if I if it will tell me something like the battery is going down or something, so there need to be some feedback. So like vibration, for example, right? So vibrate, and I mean, oh, something's going on. Then this was a very special idea by myself. It was when I have the team sitting in a car using a notebook or sitting in the office somewhere, tracking me running down the road. How can they contact me? That was something where I'm thinking of, there is this text-to-speech thing, right? Wouldn't it be nice when they can just text me and then the computer would talk to me and tell me the message? So this is just, like I said, that was my own requirements that I put on here. We will see how far I got. Then some obvious things like switch it on and auto shutdown, which seems to be very easy to do, but it's not. Who has a Raspberry Pi, by the way? Ever tried it? Program it? Nobody. Oh, that's so interesting. That's the usual case. People buy the Raspberry Pi, they do something like XBMC, but never started coding for that stuff. And if you do that, you will find out that switching a Raspberry Pi simply on by a switch is not possible. You have to put a power plug in and then it starts, right? So then there are tricks to switch it on, but auto shutdown, that is possible, for sure, you can do that. But things like that, right? So you really have to think about that. And it should run on batteries. Sure, I would like to take it with me. So it should monitor the battery. If the battery is going down the drain, I would like to know it, and it then should shut down itself to save the battery life. Because if you have a lithium-ion battery, then it's really important that you keep it a little bit of charge in the battery. Otherwise, if you really discharge it completely, it will break. Right? So stuff like that you have to keep in mind. And that was the ideas that I had. And yes, because I like MQTT, then years ago I liked XMPP, but then when MQTT came up, it's even better than XMPP, so I used that one. And so I thought it would be nice if this device would publish the data via MQTT, and I will come to that later on. So the platform that I choose, Raspberry Pi, which is big, right? But it's programmable with Java SE8 embedded, which is in principle the same as on the desktop. You just miss some parts in the JavaFX part, but in principle the Java part is the same, which makes it very convenient because I can code everything on my MacBook. I can test it on the MacBook. I can run it on the MacBook, and then if it works, I can just deploy the jar file to my Raspberry Pi, and I'm good to go. So let's talk about the sensors and actors that I built in that tool. First of all, to track the location, I tried different things, and this is just a short overview. I tried many more. So I tried this one, which is the so-called Flora GPS. It's a very tiny, like this size, GPS sensor, and the good parts are it's very easy to set up. Did somebody ever played with a GPS module like this? Nobody. Okay, that's great. So it has RxTX, right? I think you might know that. A serial connection, a UART. So that means as soon as you connect it to power, it starts collecting data and then put it on a serial port just out. You can read it. It's just text messages, so-called NMEA. And this thing has the advantage that it's very easy to set up. It's small. You can attach an external antenna, which is very great. And it has a very low power consumption. And power consumption is a very important part when you talk about wearables. This has only 20 milliamps, which is really small when in tracking mode. The disadvantage is this is GPS only. Sure, it's a GPS receiver, right? But if we take a look at this guy, it looks similar, and this thing is just the antenna. But this guy has, in addition, temperature sensor, pressure sensor, accelerometer, all in this little tiny case, and it has again the NMEA output. That means you connect it to power, it starts collecting data, and just put it on the serial port. You can just read it and interpret the data. So that's very nice. Drawback is the power consumption is more than double than the other one. Advantage is this is really fast. It can go up to 50 hertz, which is very fast. You can use it for drones, for example, if you need very precise GPS tracking. The other one was going up to 10 hertz. which means 10 values per second, which is still very fast if you hook it up to a runner, right? So you just need 1 value per second. That's enough to track the position. So reading out the stuff is as easy as this if you use Py4j. Does someone know Py4j? Yeah, 2 guys, 3? So this is a library that wraps, it's a Java library that wraps around the wiring Pi, which is a C library that makes it possible to connect to all the pins on a Raspberry Pi. And if you use that library there, you can just create a serial, which is the serial port of the Raspberry Pi, and then you get just events. You hook up a listener, and then you can just get events with get data. You get the string. It's just a string separated by commas, which contains latitude, longitude, and all that stuff. And this, I just wrote parsers that can then parse the data out that I need. And because I think most of you don't know the NMEA sentences, this one is not in the standard. This is very special for this second GPS receiver. They simply added an additional sentence, which they named STI sentence, and that one contains temperature, pressure, accelerometer data, which makes it very convenient because it just puts out the additional data also on the serial port, and you just read it like the others. Very nice. Then when we go to the next sensor that I hooked up was the tracking heart rate. Well, first of all, I was thinking, how to do that? Is there anything in the field? And I stumbled upon this thing, which first of all looked great. And you have just 3 pins. You hook it up to the Pi. And then here, this is a simple LED. And you connect it to your finger. And then the blood flows through your finger. And if the heart beats, then the reflection from the LED can be measured by this electronics. Sounds nice, works not so nice, and you can imagine running around with a cable from here to somewhere that also doesn't look very good and feel very good. So that wasn't really it didn't work out for that project. I tried it and I got it working, but it was not that reliable. So then I found this one, and that's very great. It's, who knows Polar? Yeah, many people know that, right? And they have some kind of a so-called educational kit. And with this educational kit, you get this little sensor. And you get a strap that you can wrap around your chest. And then this just collects the pulse, and that's all. And for each heartbeat, it will send a 15 millisecond pulse, and that's it. So that's very easy to set up. And the only drawback is you have to calculate the heart rate by yourself. So there are also modules from Polar that are a little bit bigger. That's the reason why I didn't take that once. And that also automatically calculate the heart rate for you. So you don't have to do that. You just get the heart rate back. Here you have to calculate it by yourself. But I figured out how to do that, and it worked quite well. I checked that in a gym with a professional one, and it was nearly the same value. So that's okay. And that's how you get the data. That means this is this Py4j stuff. You see I have something like a GPIO pin digital input. That means I just hook the sensor up to a digital I/O, and then I define this pin where I connected the heart rate sensor as a digital input pin. And the good thing is that I can just add a listener that listens to events. That means if the pin goes high, then I get an event. And that means I can count the heart rate. And what I do is I just call this beat method in my heart rate monitor class, which is just the calculation of, I just make sure that the heart rate is not too high, not too low, because sometimes it can happen that the signal was not good enough and then you got a 0 or you got a whatever 3000, which isn't really true. So you have to filter that out. And then I just take 10 beats and divide them by 10. It's a very simple approach, but it worked. So with this approach, I can calculate the heartbeat. Well, coming to the next point, which is the haptic feedback, the vibrational thing, it's, again, I was searching for Adafruit or who knows Adafruit and SparkFun. Yeah, that's great. So you will find all that stuff there. And I found this little guy, which is a LilyPad Vibe. It's really small like this, and it's a vibrational motor. And I stumbled upon that idea when I was I was playing around with my company phone, which was an Android phone, and there is something like you can define vibration, some kinds of, how to say that, vibration patterns, right? And I liked the idea and thought, that's great, because then I can define my own vibration patterns for different situations, like battery running low 5 times. If it's whatever, you can also do something like SOS, and you will feel it, right? And you know SOS, it's really simple. So stuff like that. So I bought this one, very cheap. I think it's $16 or something, and very easy to hook up. You just have to hook it up to a digital I/O and set on or off. That's all. As long as it's on, it's vibrating. If you switch it off, it's off. That, simple as that. And again, this time I defined the pin as a digital output pin, and then you can just say pin high, pin low, and I just sleep for a certain duration or whatever. So this is very simple approach, but it works. I did more than this. This is just demo code. So I did more. I just created sequences where I can just put in a sequence, and then I can just play sequences, and yeah, that's fun. Well, this one, that's the most fascinating thing. It's text to speech. Who knows what it is? Text to speech? Did somebody ever try that? Yes, great. Some tried it. So what my tool does, it tells me every minute my heart rate, and it gives me the possibility to get custom messages out. And let me see, because I'm not sure if I added to the slides. Maybe you can hear it.
Java 1 rocks.
Ah, it's talking to me. Let me see. Can you hear that? Let me see. That should be.
Your heart rate is 98 beats per minute.
That sounds quite good, right? This is a professional voice that I bought, and
Java 1 rocks.
yes, now it's enough. So if you go to this website, to sepstral.com, they have text-to-speech voices that are around 29 euros each, and you can buy it also for platforms like Mac or Windows. And I knew that company because I built years ago, I built a bug tracker that tells me who posted the last bug. So I know, oh, that was an important one, oh, that's not important, from sales or something, right? So this was talking to me, and I remembered that, and I checked the website, and they had one voice for the Raspberry Pi. So I bought that one to get good quality, because if you use the Linux-based stuff that is available, there are also free text-to-speech engines. They sound terrible, like robots. It's like, your heartbeat is, it doesn't really work out. So this one is great. The drawback is there was no Java interface, and to be honest, I was too lazy to write one. So there is a shell access. Well, there's a command, it's called Swift, nothing related to Mac or Apple, and this is their command line tool to put out speech. So just do this little method and then use it on the command line, and it works perfectly. So why writing a wrapper just to have it in Java if I can do it like this? Well, with this approach, you can imagine I can send messages now to my device, and it can talk to me in a high quality, which is really nice. Because what I also added was stuff like when I was running around, I have a desktop app, and I will show it to you. And the desktop app knows exactly where I am, and it gets the weather from my location. And if there's a weather warning, it sends me a message. Be careful. 5 kilometers up front, there is a storm coming up or something like that. So things like this, you know, if you start with that playing around, you get more and more ideas what you can do. It's really, really fascinating. So connectivity, this is, I think, the biggest part with all the wearables. And it means really heavy lifting. Because if you have to go to the internet, then you can imagine, if you have, like I said, if you have your mobile phone, like I have this smartwatch here, right? This is a phone. It even has a webcam. And this phone runs, if I really use it, for 2 hours, and then the battery is empty. But at least you can use it for demo purpose. That means if I look at independent internet access, means I would like to have a system that is autonomous, so that doesn't need an additional tool, just really can connect to the web by itself. Then I'm bound to something like 3G or LTE, for example, and I tested this tiny guy, which is a 3G stick. right? You can use it at your MacBook, and because the Raspberry Pi has USB ports, you can use it on the Raspberry Pi. But let me tell you, it took me a week to set it up running on the Raspberry Pi. But I got it working, and yeah, it was a challenge. The advantage is, if it works, then it's fast. Then it automatically connects to the web, which is not forgiven, right? So not every tool connects automatically. Some tools recommend that you have to log in and do stuff like that. This one not. You can just set it to auto-connect, and as soon as it gets power, it connects to the web. Well, like I said, the setup was terrible. There are so many different, because only a few sticks are supported on Linux for the Raspberry Pi. Not everyone works. So you have, first of all, find one that works. Then you have to figure out how to get it running. And for some sticks, you have to break to get them running correctly. So that really, it was a mess. But the biggest problem was it drains a lot of power from your battery. So if you know what that means, 300 milliamps, then you know that this is a lot. And that means you need a big battery. So I tried that with, I got a power pack like that size and that thick, which is 13,000 milliamps. And I hooked that up to the Pi with this stick. And 3 hours later, this thing was empty. And usually I can charge my cell phone with this thing 5 times or something like that. But running with this 3G stick, it really drains the whole battery in 3 hours, which was terrible. Well, and the other thing was the form factor. You can imagine this is a stick like that long, and if you have a wearable device and then it sticks something out like this, then it's not really the thing you would like to use. So then I tested one other thing, which is a 2G, fast enough for what I'm doing, and that is this one. This is the Adafruit Phoner, which is a complete cell phone, right? This is a cell phone which can also send SMS messages, it can get short messages, you can really make a phone call with it. You just have to hook up microphone, keyboard, and all that stuff, but then it would work as a phone. It's quite small, and it's based on this SIM 800, and there are also, you can even get smaller with this, modules like a SIM 900 and SIM 908, but I bought this one because I like the idea to have a phone with me in this tiny device. That was great. Full mobile phone, very flexible, you can do whatever you like. Think about sending SMS or short messages or receiving short messages, was a great idea. Drawback was, again, power consumption is quite high. It was more than 200 milliamps, and it means this guy, it needs its own battery additional to the Pi, which was not very suitable. It got too big, right? So, and then the Pi needs a battery, right? So the form factor was really the drawback. It got very, very, very big and not really useful, so I skipped that idea. And then I did the easiest thing when going to the dependent internet access. I just took a look on the market. If you take a look at the Apple Watch or the Google Gear stuff, what are they doing? You have a watch, and to go to the internet, it uses your mobile phone. So easy, right? And then I thought, right, my mobile phone, I have it always with me, even when I do sports. So why not use the internet connection from the phone, because phones are made to that in these days, right? We have all these smartphones that are made for internet access. They have Bluetooth tethering or Wi-Fi tethering, so I could use that one. Well, then I started with Wi-Fi first, and I found a very interesting device, which is this one, which is a TP-Link M5360, and this is a power bank with a 3G hotspot in one thing. That means you can power the Pi from that thing, and it has also internet connection, and it has LTE, so it's really fast. So that was the one thing I tried, and it has like I said, it's a Wi-Fi hotspot, and you can connect up to 10 devices to that thing, and it has a high data rate. It has up to LTE if it's available. At the same time, it's a power bank. That means the Pi can be powered from this thing. It has a USB outlet at the bottom, and it has a 5,200 milliamps battery, so which is quite a lot. And the heavy lifting for the internet connection is done by the hotspot, right? So you don't have to take care about that. That's very easy. Well, the drawback was the form factor. It's not that big, but it's in the size of a mobile phone, a little bit thicker, but in principle like a mobile phone. And yeah, the power consumption with Wi-Fi is around 116 milliamps. That's what the spec says. That means the Pi needs up to 116 milliamps just for the Wi-Fi connection. In the beginning, that sounds like a good idea, but then thinking about it, then you figure out, wait a moment, I have this Pi, I have this 3G Wi-Fi hotspot, and I have my mobile phone. That doesn't really make sense, right? So you have one tool in addition that you, in principle, don't really need. So I switched to this idea, Bluetooth smart or Bluetooth low energy. And that means the whole solution is this one. You just buy a little tiny BLE USB stick, which is very cheap, and it's also small. It's the only thing that sticks out of this case in this version. The next one will have it inside. And then I can use my mobile phone, and that's it. And the big advantage when using BLE, you will see, is the power consumption. So you need a phone that is able to do Bluetooth tethering, sure. And if you have that, then it just depends on the phone and on your provider what kind of speed you get. Then the power consumption is just 16 milliamps, which is a lot less than Wi-Fi. Means the Pi itself, which has to connect to the phone, doesn't need so much, doesn't need as big battery as the Wi-Fi solution, right? So this is a good idea. And the heavy lifting is done by the phone, sure. The drawback is the Pi needs a battery, all right? This is really something you have to address, and that's not easy. Because the Raspberry Pi has no connector for a battery. It has a USB charger. You can put a USB thing in and a USB plug and then use a power pack or something to draw it. But the problem with this one is the Pi has no idea about the battery. If it's running low, then at some point the battery just doesn't deliver enough power anymore and just shut down. And you know what happens if you have a Pi and you shut it down? The SD card is corrupted, and then it's a hassle, so you don't want to do that, right? So that was really a problem. It just looks like a small point, but it's a big one if you work with a Pi. So let me give you a short overview. If we compare these different solutions like this 3G stick and the Phonar, which could also be the SIM900 or SIM908, which is a similar approach. And then you see the data rates of all these approaches. And then the weight compared to each other and the power consumption, which is really the biggest part here, right? And if you really be honest, then you will figure out only Wi-Fi and BLE is the way to go. And because the reasons I told you already, that if you have an additional phone and the hotspot doesn't make sense, in the end, Bluetooth is the way to go. And that's the reason why you see all wearables using Bluetooth, or ANT+. ANT+ is also good for that. Well, now some words about communication. I told you I like to use this MQTT, which is message queue telemetry transport protocol. And who knows what it is? You don't have to. Now, behind you, these guys are very big in the business of MQTT. So who else knows MQTT? Okay, that's good. I would just give you a very short idea what it is. So it's all about publish and subscribe, which makes it the perfect model for this kind of approach, because I have one thing that publishes its data, and I can hook up as many subscribers as I like. And that's the biggest advantage of using publish and subscribe for this kind of things. Because, for example, when I started, I just collected the data and showed it live. Nice. Wouldn't it be nice to save it somewhere in a database? Well, very easy. I just hook up another embedded device that subscribes to the same topic, and as soon as it should start recording, it just gets all the data and put it in the database. So you can add more and more stuff. I added mobile clients that always hook up to the same topics, and how it works is in principle like this. So you have some kind of a so-called MQTT broker, which in this case is Mosquito, and that works for me. It's very small, and I'm just let it run on a very small device. There are even more capable MQTT brokers like HiveMQ, which is running on Java, but I think as far as I got it, it's more for really big business, not this thing that I do, just 2 or 3 clients connected to. For this, Mosquito is fine. So what it does, this is my device, it publishes something to this topic, and as soon as this happens, the messages will pass through to all the connected subscribers like the clients. The way around, I have a topic when some of the clients would like to send something to the runner, I have this runner topic/message, and then the runner subscribe to this one, so I can also go the other way, right? So this is how I implemented it. Not sure if this is the right way, but for me it works very fine. So in principle, this is the way how I do the communication. The Raspberry Pi talks to the phone and do this MQTT publish, then this uses the cellular connection, and this is my MQTT broker. It's another embedded device. It's an Odroid U3 from hard kernel, running Mosquito, and then from this one, it really just, I hooked up all these devices, they subscribe to the topics, and then they get the data from this MQTT broker. So that's in principle how it works in a very short way. So, but like I said, for me, this is a perfect approach. And MQTT was made with power consumption in mind and all that, so it's really, and for unreliable connections, so it's exactly for use cases like this. That means MQTT is perfect for M2M in this case, which means machine-to-machine communication. Then it's very lightweight protocol. It's binary, so you can put in whatever you like. So not like XMPP, which is based on XML, where you have always these big things. You can also compress it, but it's never the same as this one. Then it's made for low power, and it supports this quality of service. That means I can make sure that the message really arrived at the receiver. So this is something that XMPP, for example, doesn't support, but MQTT does. And then there is a project, this Eclipse PAHO. I don't know, who knows that? If you work with MQTT, take a look at this one. It's really nice, and it's available for different platforms, not only for Java, but I use for sure the Java version. So now I talked a lot about all these uninteresting things, right? So let's talk about some hardware. So my first prototype that I built was this. Right, this was the first thing I tried to make as small as possible. But if you know a Pi, it is small compared to a desktop computer, but a Pi is big compared to stuff like this one. It kind of worked, and these are just some facts about the Pi. I used the Wi-Fi stick. I have here a heart rate sensor, the GPS sensor. This little board is called Slice of Pi. You can just put it on the Raspberry Pi, and then you can use Pi4j to connect that. That worked. The problem was, like I mentioned before, the power supply, because the standard Pi can't be connected to a battery very easily. So the solution, and I showed you this already, is this guy, right? It is this router, and it has, you see, it's really fast. It's a Wi-Fi hotspot. It has a huge battery inside, and this one can run the Pi for 4 to 5 hours. That was no problem. So I make a test ride. I put it in the car, so I was too lazy to really run, or took my bike, so I put it in the car and took a 3-hour test ride, and it was not even half the battery, because this one shows you the state of the battery, which is an advantage. Well, that means the solution that I got was this with this. That's all. And then there is a wire, of course, to power the Pi, right? This was the setup, the first setup. And then I thought this is good to go for Java 1. But lucky me that this company called Hard Kernel came up with a very nice device. And this is the Raspberry Pi that I used. And then there's this tiny guy, which is a so-called Odroid W. Who knows that board? You should really take a look at it, because I think they might have a few, but it won't be available in the future anymore. There have been some problems with Broadcom. So this is the same as this one, plus additional features. Just this is much smaller. As you can see, it fits in this case, and there's even place around it. And the Pi, unfortunately, I don't have a Pi with me, but it's much bigger than this one. And the additional advantage is that it comes without any header soldered. So it's just the plain board with a few chips, and that's it. So that means, oh, here's a Pi. Great, thanks. So if you take a look at the Pi, it looks small, but compared to this one, and I don't have the board now, but the board inside is just even not the half of this one. It's really small. And the Pi comes with all these connectors, right? It has a network connector, it has a HDMI, audio out, video out, and so on. This tiny guy comes without anything except a little USB port, and it has a small HDMI output, a micro HDMI, it's here, and a small USB port, and that's all. If you need, for example, a big USB port, you have to solder it here. And you can buy a so-called I/O package, and then you get all the headers that you need. This is the same port as this one, the old one, right? This is the B+, which has 40 pins, and this has 26. Here's the camera connector, and then there are a lot of other headers you can add. And if we take a look at the hardware spec, then this is, in principle, exactly the same as the Pi, plus it has the ability to charge a lithium polymer battery on board. Then it has a connector for that battery. It has a real-time clock on board, which the Pi doesn't have, and also a connector for that real-time battery. And it has, in addition, a 12-bit analog digital converter. So that's a really nice little guy. Unfortunately, like I told you, the company Hardkernel, they produced that thing, and the first batch, and then they offered that, and you can order it, and when I ordered that, I got 2. I was fine, and then I would like to order a third one, and then I saw on their website that they say, sorry, we won't create a second batch, because Broadcom, which creates this SoC, that means the system on a chip that is used on the Raspberry Pi, they only delivered them for the first batch, and then they said, we won't deliver anymore. That's the problem with this little guy. So I ordered another one last week, so there are still some of them available, but it might happen in the near future that they run out of these devices, and then there won't be another version. They said they will work on a new version which will come out next year, but not sure if it won't be compatible to the Pi like this. This is really like the Pi. You can use the SD card from the Raspberry Pi, plug it in there, and it works. So that means this is, and this is not even the current version one, this is a little bit bigger now. This was my second approach, and it fits in this tiny box, this is not this one here. This is in principle it's another prototype. It's my current version with a bigger battery. And I'm working on the next one, which is just half the size. So that's really, if you start with this, don't do that. You can't stop. It's so many things. So the next version will, for example, get RFID possibilities and all that thing. So yeah, it's really fascinating. In this case, I have the things that you see here. That means I have the GPS, I have the heart rate sensor, the battery, real-time clock, vibration motor. I think that's it, and then I plug the Bluetooth in here. And to give you an idea about the wiring, then if this is the board, then I have this is the GPS sensor, I hook it up there. Then the polar heart rate sensor, I have to hook it up like this, vibration motor like that. Another nice feature of this guy, it has an on-off switch. You can just switch it on, and then it works, right? You just have to connect 2 wires, and that's it. But on the Pi, there's also something like that. And then audio out, because there is no audio port, you have to solder it by yourself, which it's okay. I won't show you the next version that I'm working on, because there's so many wires that is terrible. I don't know how to fit it in the case, but I will try to do it. So that means my second version is this one. It looks like that. It's just the phone and this little guy, and that's it. I don't need anything more. So let's talk about a little bit about battery life, because battery life has an interesting aspect. This is how to calculate how long a battery will last in principle with your device. So there's this little equation here, and that means with the 1200 milliamp battery, which is the one I have in this case, it should run theoretically up to 7 hours, right? This is just an estimated power consumption. I'm not sure about that, really. And because I give it 15% buffer for the battery to keep it safe, it will run around 6 hours, and I tested that, and it really works. I can run this thing for 6 hours on battery, no problem. So, and then there are some things you can do in code, which is I have something like a little status manager, which is just a little class wrapped around one Boolean, which just says the status. That's all. And it uses JavaFX capabilities, these properties, where I don't have to write all the listeners and all that stuff because it comes with JDK8. And what I do is, if at the moment I just have two states, like recording and idle. And what I do is I just schedule futures that run either every 5 seconds or every 60 seconds and send messages. That means if it's idle, why sending messages every 5 seconds? I just keep everything down, unregister every listener, and then every 60 seconds I just grab the value, send it, and unregister again. So just to don't do anything, right? So that's the idea. And if I start the thing, then it starts with storing data internally once a second, and every 5 seconds it sets out a bunch of data, which is, then I have fine granularity in my data, and I just have to send it every 5 seconds. And it's good enough to get a live view of that. So now the question is, because I showed you this thing already, how to control that? Because there is no button here, right? So if I put it in my pocket, it's connected to the internet, nice. How to control this guy? I can switch it on externally with a switch, but now I need to do something, right? So I created a mobile app, and I use JavaFX for sure. And it's running on different devices. So this is, for example, running on this watch. And it shows me the battery state, the time, it shows me my current heartbeat, latitude, longitude, then it has an indicator of the beats per minute. That means if it's too high, the color will change. If it goes up to 200, it gets red and red and red, and if it goes down, then it will get blue. So it will be green around 140 beats per minute, something like that. Then I have the distance of my track that I'm running and the duration. And I have this little button that I can push, and it will show me a static map where I am at the moment, just to get an idea to be able to see, okay, I'm here and there's a street or whatever. And then it has, if I swipe with the finger, I get this little menu, and I can mark, for example, points of interest. So I'm running around, I can say, oh, that's interesting, mark it, and it will send out an MQTT message to my broker, and then it will store this point in a database. So later on I can check and see, oh, there was something interesting. Then I have something like an alert message. That means, let's say I'm on the bike, I'm falling down, bike crashed, I broke my leg. I can send this message, alert. So then this is a special message, and it will not only send out to all the registered subscribers, but I also added another tool, which I will come to in a minute. It's called Own Tracks. And so my idea was, if you have this marathon runner, it's running along the track, think about a teammates of that runner who can be placed along the track and give the runner something to drink or whatever, or help him, I don't know. And wouldn't it be great if these people can use an open source tool like Own Tracks on Android or on iOS and can follow the position of the runner in Own Tracks, right? And if the runner comes close, the runner gets the message, it will read to the runner and said, there are some of your teammates coming up in 500 meters northeast, something like that. And these people are hooked up with Own Tracks will also get an information that there is an alert. So and then they can go to this position and help the guy. That was the idea. Then I can start and stop recording. Okay, I can shut down the tool with this button. Then it will auto shut down the whole pile. Exit the application, and this is just to reset the track. And I implemented that for iOS, for Android, and this is also Android-based watch, and this is all running on JavaFX. And this is the same application, not similar, it's the same code. I just compile it for different platforms. There's no change at all. I just make it different for different sizes, but this is auto-detect. If the size is smaller, then it adjusts that the heart, for example, is here, and here is in the bottom, and here's on the right side. So then the next question is, now I can control it, but how can I monitor it? That would be nice, right, to monitor that stuff. So therefore, I wrote a little desktop app, which looks like this. It gives you a lot of features. It's hard to read, I have to agree. But you see, it can do a lot of stuff. It uses OpenStreetMap to visualize the position. Then it shows here, this is track data, means like highest speed, average speed, highest heart rate, average heart rate, and so on, minimum height, maximum height, or altitude that you're on that track. Then it shows you the scale, the heart rate, the height, speed, the distance, the temperature, the battery status. You can send messages. It shows you the bearing and the location. There is a calendar and also charts. And here you see if someone on OwnTracks subscribed to the same topic, it will show you also the position of the teammates here in OwnTracks in this map. Then it has, yeah, like I said, it shows you all that stuff, friend location and so on. And because it's using OpenStreetMap, you have all these different overlays that you can use, right? For example, you can use temperature overlay. So I don't have to take care about measuring temperature in general, so I can get an overview. This also works for rain, for wind, and all that stuff. So I can get an idea at the location where the runner is. I can see, oh, wait a moment, there's coming some rain. So maybe I send the runner a message. So there will be rain, maybe in 5 or 10 minutes, so be careful or whatever. Then what else? I store all the data in the database, so I can pick that from a calendar, and you can see here the track. It's a little bit hard to see, but you can see tracks, and the track is colored either with a heart rate. That means, I think there's on the next image, when I walk up a bridge, for example, then my heart rate will increase. So that means the track will get red, and then when I go down, it will get blue again. So I can take a look on the track, and I see, oh, this was a relaxing phase, and this one was very, very hard to do, for example. So that means I can save that, I can restore that, I can export the stuff to GPX file, which is a standard for GPS files. So that means I can also use it in other tools. I also created a KML file for Google Earth, where you can, for example, if I would give you the link to that file, you can open it in Google Earth, and as soon as I start running, you will see my position updating in Google Earth, because I update that file on my server, and so you can then see live where I am, and will also show the beats per minute and the height of my sensors. And what else? Yeah, it shows points of interest, sure. And this might be hard to see, but this is a bridge, and you see here it's a little bit more orange, and here it's blue or greenish. That means when I walked up the bridge, then it was, it seems to be a very, very tough angle, because it was more than 100, I don't know, 60. Maybe I should do more sports. But this is very interesting to see if you use a bike or whatever, or if you just run, to see afterwards, okay, here that was a tough part of the track, and the other one was, oh, that was easy one, right? So this is, and you can also map it for speed. For example, if you take a car on the racetrack, sometimes interesting to see how was the speed on certain parts of the track. I can also do this one, because I also record the speed of the runner or whatever. You can add it to whatever you like, or the biker. So then I for sure have graphs for altitude and beats per minute of my heart, because there's a relation between that. I can send text messages. I mentioned that already. And I have the weather location and the weather of the location of the runner. That means I know about the weather conditions roughly at the position of the runner. At the end, my final setup looks like this. This is, I have this sports holster, because you might ask yourself, how can you wear this clunky thing when doing sports? And this holster is very nice, because it was made for that. You can put it on, you can make it really that it fits to your body. And then I need this polar heart rate strap, which is a standard thing, and my phone, which easily fits in this pocket, and this one fits in that pocket, and then I have just headphones that are hooked up to the thing, and I'm good to go. So this really works for sports. And the future improvements will be this tiny guy, which is a so-called warp board. And unfortunately, it's not available yet. You can pre-order, and I did that 4 months ago or something, and they told me it will be available mid of November. And this is based on an iMix6 CPU, which means it will run Java without any problem. And that's very, very tiny. It's like that size, maybe this size. That's the whole board. Very small. very powerful, and it has Bluetooth and Wi-Fi and accelerometer, magnetometer inbuilt already. So that means I can just hook up a few different sensors that I need, and I can go really much smaller than I did right now. And this is also less power consuming than the Pi, because this one was built for low power consumption. The Pi was not really. And then I'm also playing around with this guy, which is not really small, but the interesting part is this is running on a Cortex M4 CPU, which means it has only 256 kilobytes of RAM. And you can run Java on that one. It's Java ME8. And in Java ME8, we have something similar like the Pi4j. It's inbuilt. That means we have a direct I/O API. We can directly hook up to all these pins from within Java without using additional libraries. And I'm working on that one too, and it seems to work. We are getting there. Let's name it like this. So I'm not very satisfied at the moment because it's really different from the Raspberry Pi, but it works. So you can really do that. You can run Java on 256K, which is really nice. Well, and I guess I'm through with my stuff, and thanks for attending. If you have any question, you can also come up front and you can take a look at that stuff, or if you have any question now, then feel free to just ask. Yes?
Since you're struggling with power efficiency, do you consider any sort of solar wearable to supplement?
To be honest, not. Yeah, the problem is always the weight of that stuff. It's really, if you have solar, it doesn't work alone. That means you need a battery, because solar alone doesn't work. And if you need a battery, then for solar, you can't use this lithium polymer things. You need something like really heavy stuff. And that's just too heavy. So that's the reason why I never tried that. But in principle, if they would improve it more, then this would be for sure a nice approach. Yes. So any other question? If not, then thanks for attending.